Hello and welcome to More Interesting Maths. I'm David Myers with UTC South Durham. In this series we are looking at GCSE mathematics. This is for those of you that want to revise for your summer exams, catch up on any materials that you may have missed, or if you're a parent that's wanting to help your kids out at home. Generic introduction clip over, now let's do some maths.
So ladies and gents, if you've been keeping up, then we have looked at one particular form of factorisation. We've done a fair bit of work on expanding brackets and expanding double brackets to get quadratic terms. Last video that I put out, we looked at factorising out a single term. We were looking for the common factor in both of them, which we could then get rid of or pull out of the brackets. We could factor it out to get back to the two original terms. Today's lesson, we are looking at quadratic factorisation. If we've turned something into x squared plus bx plus c, say for instance this over here, how do we turn it back into its original counterparts? And there's an incredibly important step here, so I'm going to transfer you over to my OneNote page, which is going to help us make a little bit more sense of it. Because we need to be very, very careful with some of the structures when it comes to quadratic expansion, in order to understand factorisation. In the same way we need to know what we're doing when we're dividing, we needed to understand how multiplying worked. As in, 6 divided by 3 is 2. How do we know this? 2 times 3 is 6. We need to understand the link between these two. So let's have a very, very good look at what we're looking at here. Bear in mind, some of you sat at home might have been taught this already and want to cover it as a review. Your teacher will have said to you, you're looking for two numbers that multiply to make the final number and two numbers that add to give the number in the middle. And that's fine, that's perfectly true, it's a reasonable way of doing it, but it doesn't give you a good understanding of why that is. So we're going to tie that up to begin with. If we were to expand this bracket over here, x plus 2 times x plus 3, you can see I've already done it. We get the lovely grid down here. And I'm adamant about the grid, and this is why. You will notice we got x squared, that's fine, we would expect to see that. When we multiply x plus 2 by x plus 3 is in here and x plus 2 is down here. X times 3 gives us this 3x. So I'm just going to circle that in the blue, and some of you might have spotted why that is. X times by 2 gives us 2x. And ultimately we know that we can add those together. They will be added together to give us this 5x when we simplify. And then what do we get when we do 2 times 3? We get the plus 6. That has been multiplied to give us the final value. And again, going back, the 2x and the 3x have been added to give us this 5x. So if I were to give you some hot example, I'm straying away slightly here. Let's say I came up with, let me try and be nice to you, x squared plus 14x plus 40. Somebody will have said to you, two numbers that multiply to give 40, so I'll highlight that in blue, that would add together to give you 14. And you're sat there thinking, could be anything. So you might think about the factors of 40. You might think, well, 1 times 1 plus 40, that doesn't work. 2 times 20, but if I add those together, I get 22. How do I know this is all working? Eventually, you'll start to spot that you'll come across 4 times 10. 4 and 10 do multiply to give us 40, and they do add to give us 14x. So you'll have been taught just to write that as x plus 4 and x plus 10. But it would always be handy to check that. So we chuck it into our grid method as always, just to see. X plus 4 we'll put on the top, and x plus 10 down the side. Quick expansion, x squared, x times 4, that gives us the 4x. X times 10, that gives us the 10x. And 10 times 4, that does indeed give us 40. So the 40 dropped out almost immediately. 4 times 10 to give us the 40. That's perfect. And am I convinced that we've got the other two right? Here's the 10x, here's the 4x. When they add together, we do in fact get the 14x, so that must be correct. So that's why we're looking for two numbers that would multiply to give the final value, to give 40 at the end, and then two numbers that would add to give us the coefficient of x. But there's another beautiful thing we can do with that. If we jump back to the PowerPoints, then you'll be able to see something that I claim is really quite nice. Using that quick step, using the fact that the two numbers will add to give the number in the middle, these two numbers add to give us the number in the middle, and multiply to give us the number at the end, that actually makes expanding the brackets quite a nice little trick. We don't have to draw the grid method. It's helpful to, and it's handy to understand why it works, why this little technique works. But if I just wanted to expand this very, very quickly, we know it starts with an x squared. 4 plus 2, that gives us 6, so that will turn into a 6x. And 4 times 2 gives us 8. X squared plus 6x plus 8. X plus 7 times x plus 5. 7 plus 5 gives us 12, so this becomes the 12x. And 7 times 5 gives us 35. Finally, 8 plus negative 3, well, that's the same as 8 take away 3, so that'll become a 5x, and 8 times negative 3 is negative 24. X squared plus 5x minus 24. So that's a nice little trick if you want a quick way to expand simple brackets. Shifting on, we now use this trick to factorise, to get back into the brackets. We know that if you want to represent this algebraically, x plus a times x plus b, x squared plus a plus b times x plus ab. A and b were added together to give us the x term, a and b were multiplied to give us the final term. So with something like this, x squared plus 3x plus 2, when we want to factorise it, can we think of two numbers that multiply to give 2? Well, 2 and 1. What's nice about 2 and 1? They add to give us the 3. 2 times 1 gives us 2. 2 plus 1 gives us 3, as required. Therefore, if I were to factorise this expression, we would be left with x plus 2 times x plus 1. You've got to do a little bit of work with something like x squared plus 11x plus 30, because you need to write down the factors of 30, I would argue. I think it's going to be very good practice for you. Sometimes you'll see it immediately, sometimes you won't. I would get yourself into the habit of writing out the factor pairs for any number at the end. So here we've got 30 times 1, a fairly obvious one. 15 times 2 gives us 30, 10 times 3 gives us 30, and 6 times 5 gives us 30. How can I be convinced that that list is complete? What I like to do is just go through my times tables. We know it's in the 1 times table, 2 times table, 3 times table. Is it in the 4 times table? Nope. So we can ignore that. Is it in the 5 times table? Yes. 5 times 6 gives us 30, but we know we can stop there because the next factor is 6, which we've already covered. So we know we're done. And I'll show you what I mean by that in another example. The question here is, which one of these numbers, we know that all of these multiply to give 30, which one adds to give 11? Well, 30 plus 1, that's 31. Nope. 15 plus 2, now that gives us 17. 10 plus 3 gives us 13. 6 plus 5, that gives us 11. And it's the 11 that we require. We needed the two numbers to add to give 11 as well. So it must be this pair down here that become our factors. X plus 6 times x plus 5. A couple of further examples for you. So I'll chuck these in pen. Let's think about negative 24. And there's a nice little way to do this. Negative 24. So we know that 1 times 24 will work. You'll notice I'm ignoring the negative sign for the minute. We know that 2 times 12 would give us 24. Is it in the 3 times table? 3, 6, 9, 12, 15, 18, 21, 24. Yes, it is. 3 times 8 would give us 24. Well, what about 4? 4, 8, 12, 16, 20, 24. Perfect. That gives us 4 times 6. Is it in the 5 times table? No. That's hopefully fairly clear to begin with. And the next factor is 6, but we've already got 6, which means this is the list of whole number factors for 24. Now, because we're looking at negative 24, there's something quite nice that would spring to mind here. You'll know that to get a negative when we multiply, only one of the numbers can be negative. Positive times a positive would give us a positive. A negative times a negative would give us a negative. So one of these has got to be positive. One of these has got to be negative. But which one? Well, I'm trying to make minus 2 when I add two of my numbers together. So I could do 24 take away 1. That's not going to work. 1 take away 24. That's not going to work. I'd end up with 23 and negative 23. Neither of those will work. What about 2 and 12? Well, 12 take away 2, that would give us 10. And 2 take away 12 will give us negative 10. That doesn't work. 3 take away 8, that would give us minus 5. And 8 take away 3, that would give us 5. Yes, by the way, this pattern that you're seeing, for those of you that have spotted it, that is always going to happen. 6 take away 4, that gives us 2. 4 take away 6, that gives us negative 2. Ah! That's what we're after. And what did I say just before that? 4 take away 6, that will give us negative 2. What does that mean? We are looking at x plus 4 and x take away 6. That is this quadratic in its factorised form. I'm just going to redraw this one up here. Will I? Do I have enough room? Yeah, I'll redraw the second example up here. X squared minus 5x plus 6. Factors are 1 and 6. That's actually not too tricky. We've got 1 and we've got 6. We've got 2 and we've got 3. So looking at this one, here's the weird trick. We now need to find a way to get our multiples result as a positive, but when we add them, we want negative 5. We're looking at this fairly quickly. 1 plus 6 is going to give us 7. 1 minus 6, that would give us minus 5. So we're on to a winner here. And what about 2 and 3? 2 plus 3, that would give us 5. 2 minus 3, 3 minus 2. Well, okay, now we're having a problem. Here's the real issue. It's very tempting to say, well, why can't we do 6 and minus 1? Surely 6 take away 1, that gives us 5. So this is x plus 6 times x minus 1. Small problem. If we did 6 times negative 1, we wouldn't get this positive 6. We'd get a negative 6. So what other rules can we remember? We know that to get a positive number when we multiply, we can do a positive times a positive, or we can do a negative times a negative. Minus 1 times minus 6 would give us positive 6, and minus 2 times minus 3, that would give us a positive 6 as well. And what's great there is that minus 2 take away 3 would give us minus 5. X minus 2, x minus 3. So here's a quick hint that I'm just going to write for you. So let's say we've got x squared plus bx plus c. If you've got that at the end, if you've got a positive number, then you must be looking at x plus something times x plus something else. Or you're looking at x minus something times x minus something. They are your only two options. It's either a positive and a positive, or a negative and a negative. What if you were looking at some other form? That wasn't meant to happen. Cancel that. Oh. Okay, yeah, you've seen my little goof on the slide now. I want to keep that, and I want to reboot it as quickly as I can. Good, I hope you can still see me there. Coming back to the drawing. I'm not sorry that it messed up in the middle of my recording, and I'm not going back to re-record the whole thing. You might as well enjoy the fact that I still can't get to grips with this system. Let's say we had x squared plus bx minus c. What's happening there? You either have x plus something times x minus something, but that's your only option. So it's a little bit easier if it ends in a negative, because then you only have one option. Whereas if it ends in a positive, then it could be a plus something and a plus something, or a minus and a minus. It will become clear as the questions go on. So skipping you on, should have recognised that. I'm going to say test your understanding very quickly, and then I'll talk you through the logic. I'm not going to pause, I'm just going to get started straight away. You know well enough whether you want to pause or not by now. To begin with, we're looking at x squared plus 6x plus 5. It's really quite a nice one at this point, because the only factors of 5 are 5 and 1. And thankfully, 5 plus 1, plus 5 plus 1, that does give us a positive 6x. So we are looking at x plus 5 and x plus 1. With 35, we need to do a little bit more work, because again, we have 1 and 35. And if you've done the maths in your head, then you'll notice that 5 times 7 will give us 35. Again, this is a positive value, so we can either have plus 1 plus 35 or plus 5 plus 7 and so on. We need to make 12. We need to make minus 12 specifically. There's no way 35 and 1 will do that. 5 and 7 will give us 12. But because it's a negative 12x, we need negative 5 and negative 7. Minus 5 minus 7, that gives us negative 12. And minus 5 times minus 7, that will give us plus 35. X minus 7, x minus 5. Coming down to the next one, x squared plus 5x minus 14. To begin with, we've got 1 and 14. We also have 2 and 7. Because it's a negative, we can only have one of them as a negative, so we can either have, say, minus 1 and positive 14, or positive 2 and minus 7, and so on. So we notice at this point there's nothing we can do with 1 and 14 to get 5. With 2 and with 7, we can get a 5. We can do 2 take away 7 or 7 take away 2. 2 take away 7 would give us a minus 5. We don't want that, so we want a positive 7 and a negative 2. As in 7 take away 2 gives us 5. Thus, when we factorise, we have x plus 7 and x minus 2. X squared plus 6x plus 9, that's quite a nice one, because we can think of 1 and 9. There's no way that's going to give us 6. Well, what about 3 and 3? 3 times 3 is 9. 3 plus 3 gives us 6. So this is x plus 3 times x plus 3. Remember what that squared detail does for us? That's telling us over here that we have our x plus 3 times x plus 3. And what about down here? What about x squared minus 6x plus 9? Well, that's just the same, but in reverse. X squared minus 6x plus 9. Minus 3 times minus 3 is positive 9. And minus 3 gives us minus 6. Jumping on, I'm going to take my face out of the way in a second. As always, have a go. Today I'm feeling the even numbers. The even numbers are going to be the first to go, and then the odd numbers will be revealed afterwards. Don't worry too much about the killers, but I will give you a hint, certainly for the first one. X squared times x squared is x to the power of 4. You can use that trick to your heart's content. The awful questions on the lower right-hand side. Can you factorise out a common term to begin with? Say, for instance, x to the power of 7. Wouldn't it be nice if you could take all of those straight out of each of the terms? And that is it for today, folks. You have taken another fantastic step in the maths journey. Why? Because like you learned subtraction from addition, in the same way that you learned division from multiplication, you've now gone into quadratic factorisation from quadratic expansion. You've done a heck of a lot of work if you've been keeping up with these videos over the last week and a bit, and it's only going well for you. This obviously does get a little bit more complicated because you need to look at quadratic factorisation with 3x squared, 4x squared, 5x squared, but you're doing incredibly well. If you did questions 2, 4 and 6 and went, no, that didn't make any sense, wait a minute, I've realised the mistake and sorted it out for questions 5, 7 and 9, you've done incredibly well. If you even vaguely understand where the answers came from in the killer questions, you've done incredibly well. It's all about taking those little steps, and you should be incredibly proud of yourself. Well done.
And that is it for this video, ladies and gentlemen. Thank you so much for watching. If you think it helped you out with your maths revision at home, then please click subscribe to get notifications on future videos. Share it with a friend if you think it will help them as well. There is a PayPal account, but please don't feel obligated to do that. 10 or 12 pence if you think that it's worth it for you at home and you liked the video and the content that I've put out. Failing that, thank you so much to Dr. Frost Maths for the slides, for UTC South Durham for inspiring these videos, and most importantly to you at home for watching. I'm David Myers. Take care.